Hi, I'm Sarah Placella, CEO of Root, and we're helping farmers grow more food with fewer inputs. We're tackling the problem of airborne pathogens. Unfortunately, we're all a lot more aware of airborne pathogens this year than we were last year. Airborne pathogens have been a huge problem in agriculture throughout time. They decimate a wide variety of crops, staple crops, specialty crops, row crops, you name it. They're Our current way of dealing with airborne pathogens is the same thing we've been doing since World War II: intensive prophylactic spraying. It's wasteful, it's expensive, and it's not completely effective. Agriculture spends $32 billion a year on fungicide applications. That's the cost of the fungicide plus the cost of applying it. Even with that, 70% of crop loss due to disease is from fungi. That's $90 billion a year. Now, not all fungi are airborne pathogens, and not all airborne pathogens are fungi, but soil-borne pathogens are more predictable. Here's the example of spinach. Day zero, beautiful, healthy spinach. The pathogen arrives in the air. You can't see it. Around day seven, symptoms develop. That's the first time that a farmer would know that there's a problem. And once symptoms develop, it's too late. The crop will be lost. Our solution is automated pathogen monitoring using IoT devices that do in-field DNA analysis and send notifications automatically to a grower so that they can spray only when they need to. The result is a 50% reduction in fungicide applications, and that's based on studies done by the USDA. Our product works like this. We collect spores from the air. We run a DNA-based assay to measure the quantity of spores of that specific pathogen. Right now, we're doing it in the lab, and soon we'll have it automated in the device soon. And then we inform the farms of the pathogen risk. Right now, we can detect a single spore. We can detect in the greenhouse or in the field. We're doing the analysis in the lab, but we have a pipeline worked out that we're ready to automate into the device that's robust. We've had a pilot in spinach where we had 10 units deployed continuously for 2 months at the beginning of this year with no reliability issues. We've weathered 50 to 70 mile per hour wind gusts and days of rain. We've also had third-party independent validation by this USDA scientist who's been working in this arena. Our traps collected 20 times more spores than his gold standard traps, and we're working together to provide him with devices for his next experiments. The key to successful commercialization of this technology is it needs to be accurate, which means it needs to be DNA based. It needs to have fast, regular turnaround twice a week so that farmers have a chance to respond when the pathogen is high with a spray. And it needs to be affordable so that it can be deployed regularly across farms. We have a wonderful team. We have a ton of Berkeley and citrus connections. I'm Sarah Placella, the CEO. I did my PhD here in environmental science policy and management. I then did postdocs at Michigan State's Kellogg Biological Station and INRA in France. Before entering industry, I realized that my work would have more impact there. So I joined a biotech startup and later an ag tech startup. While I was at the ag tech startup, I became product manager and I was talking to growers. I realized that a lot of their problems are problems because we've never converted the science into useful, accessible tools. And that's why I started Root. I've led some very large teams before, and I've done pioneering work in molecular biology. Michelle Ma, our head of product strategy, is also a Cal Bear. She did her bachelor's and master's here in mechanical engineering. And Andrew Gillies, who leads our engineering efforts, did his PhD here in mechanical engineering. We actually met Andrew through Citrus. Unfortunately, with COVID, we weren't able to take advantage of all that Citrus has to offer. We were really excited to use the Invention Lab and Jacobs Hall for prototyping. But while I was talking to Kira about some of the challenges that we were having and some questions that we had, she said, let me introduce you to Andrew Gillies. I think he'll be able to help you. And Andrew is so wonderful. He's such a great addition to our team, not just for his wonderful skills in robotic automation and experience in manufacturing, but he's also a wonderful person. And his former company, Dash Robotics, was one of the first Citrus Foundry teams. We also have wonderful advisors. Rodrigo Almeida holds the chair in plant pathology here at UC Berkeley. And Heather Koshinsky is someone that we met through Skydeck, another excellent program in the Berkeley ecosystem. Tom Christensen, our agribusiness advisor, is someone I met while I was working at the last ag tech startup that I was part of. And he's been in ag tech startups as well as worked for some of the large agribusinesses that you have all heard of. We've made an amazing amount of progress this past year, from really pre-prototype to now we have pilots. We're signing folks up for pilots in grapes this spring. And citrus has really been a beacon for us. Mikhail, Kira, and Maher have all really helped us in our times of need. And I want to say thank you to the Citrus program, and thank you to all of you for supporting the Citrus program.